Alright, let's do a couple examples just to refresh. So when we are naming an ionic compound, in these problems, if I'm giving you a chemical formula, I just want you to do the name. If I'm giving you the name, I want you to give me the chemical formula. So let's do a couple examples. Remember, you should have your polyatomic table and your periodic table. Let's do this. So first, when I look at this first problem, I see that there are 1, 2, and 3 capital letters. Okay, so there's nitrogen, hydrogen, and that chloride. Therefore, I know that I'm going to have to look at my polyatomic table. And when you look at my polyatomic table, I see that NH4 is called ammonium. So that's why this one is ammonium. Okay, you just say it like it is on the periodic table, or on your polyatomic table. And then that anion, we know it's chlorine when it says an atom, but remember when it's an anion, we call it chloride. Okay, so that one is ammonium chloride. Now the next one is, I'm just going to scooch this up so it's out of the way. Ooh, okay, that was the whole thing. The next one is iron. I can tell, maybe I changed my colors, it'll be easier to see here. So iron, but I know because iron is a transition metal. Oh, I changed that color. All right. I'm going to have to list the charge in parentheses. Okay, and I'm going to be able to tell the charge of this iron by knowing that it took 3 nitrates for it to work. And I know this is nitrate, first of all. If it's in a parenthesis and it's more than one element, I know I have to look at my polyatomic table. And you will look and see that nitrate is NO3 with a -1 charge. So if it is NO3 with a -1 charge, that means that if I have 3 of them, 3 -1 charges, right, I actually would have, that's an ugly 3 there, but that means that I have nitrate 3 times. So 1, 2, 3 means I have a -3 in nitrates. Therefore, my positive charge must have added up to a positive 3. And you just use the Roman numeral 3 on your Chromebooks. Just type parenthesis, like left parenthesis, capital I, capital I, capital I, right parenthesis. Okay. Next, I'm going to erase all the extra stuff. Let's go to the next problem here, and number 3 here. I see that I have titanium. Right, so just look to my periodic table, and I can tell that titanium is in group 3 through 12. And what that means is that it's a transition metal. So remember, groups 3 through 12 are transition metals. I'm just going to say T metals for now. But that means that I don't know the oxidation state unless I tell you it. Think of it if you, oh, I didn't even finish this one up here, sorry, nitrate. Again, just look at the polyatomic table, NO3, nitrate. Alright, titanium. Alright, that is number 22 on your periodic table. And again, because it's a transition metal, I'm going to have to put charge in parentheses, and I know that that is bromide. Again, if it is an anion, you're going to have to remove the ending and add IDE. That's how we say the anion of any anion. Okay, but now I'm going to try to figure out what the charge is. Well, I know bromide is a -1 because it is a group 17 non-metal, and there's 3 of them. So again, visualize if I have bromide, bromide, and bromide, I have 1, 2, 3, a -3 net charge on just my anions. So if I have just 1 titanium, it means it had to have had a +1. 1, 2, 3. Again, there we go. Nope. Eraser. Alright. So our next one is copper. I'll switch back to pink. Try to make it easier to see. Alright, so I've got copper. And I know, again, it's not pink. Copper is definitely a transition metal, so I'm going to add my parentheses here so I can fill that in. And phosphorus by itself is just an anion. So I'm going to go, remember, just say it like it is. So phosphorus normally, but we're going to remove the ending, that OS, and add phosphide. Add the dash IDE. Remember, if it is just a single element as an anion, the ending will always end in IDE. Now what I have to figure out, though, is what is that charge on that copper? Well, you can look to the anion because he's a main group metal, and you'll be able to figure out his charge because he is in group 15. He had a 3- charge. So if that was a 3-, you can also see the reverse crisscross going on here, right? That 3, this is technically 1, so that had to have been a +1. You can also think if I have 1 phosphorus, that's going to make up a 3- charge, and I've got 3 coppers, what must that charge be to get to -3? Obviously it had to be a +1, +1, +1. Alright, so to show the +1 charge, you have to put in 1 in Roman numerals. This is the only instance where if there's 1, you have to say it, because you're saying a charge, not a quantity. It's easy to assume if it's written there that there's a quantity of 1, but you can't do that so much when it's referring to the charge. Alright, I'm going to jump down a couple here. Got it locked. Let's do this lead one, and then I'll jump down to the problems below a little further here. So the lead one, we again know that lead is a transition metal. So I'm going to just say lead and make my parentheses. And if you look at your polyatomic table, your polyatomic table at the bottom, it said other ions. You can see that I can tell right off the bat that I should either have lead 2 or lead 4, so I have to figure out which one of those I have. Well, I'm going to look at my polyatomic table and see sulfate, SO4, has a 2- charge. If it has a 2- charge, and I have 2 of them, 2 of the 2 minuses make a -4 charge. So if you've got sulfate with a 2- and sulfate with a 2-, I have -2 plus -2, so my net charge over here is -4. But it took 1 lead with a positive something to get to 0. Okay, so that means that this 1 lead had to have been a +4, because I need -2 to get 0. So my lead had to have been lead 4. Therefore, I'm going to put 4 in parentheses, capital I, capital V, and then just spell out sulfate. And double check on the polyatomic table for spelling. So sulfate is with an F, whereas sulfite and phosphate. So sulfate and sulfite are with F's, but phosphate's with a PH. Alright, yeah, there's evidence here. Now we can go from main to chemical formula in the next section. So chromium, you're just going to find chromium on the periodic table and see whether or not it's a transition metal. You'll see it's number 24 on your periodic table. So chromium. And what this is telling me right here is because it's transition metal, I don't know the charge. So that right there tells me that the charge for this chromium is 6+. And phosphate, I'm going to have to look to my polyatomic table. And again, I know that because it ends in ATE. It's not phosphide, it's phosphate. Remember, at 8-1 we're oxygen and then phosphite. So look for phosphate on your polyatomic table, and you're going to see it's PO4 with a 3-. Alright, so now we're just going to do the crisscross rule. So the 6 is going to come down over here, but remember if it's a polyatomic, I'm going to have to put parentheses if I need more than one of them. The 3 is going to come down. Alright, now I really like this example because when I simplify it, when I write it here, you're going to notice that you can simplify. Now remember, these numbers are just literally telling me what's the ratio of my cations to my anions. So if you had a ratio of 3 to 6, what could then simplify to? You can divide both of them by 3, and you get 1 to 2. Okay, so my final ratio is 1 part chromium to 2 parts phosphate. Alright. Next, let's go ahead and grab tin nitrate. I'm going to erase here. Sorry, apparently decided to erase everything. Alright, tin nitrate. Tin is SN. The 2 tells me it's a 2 plus, and nitrite actually, SO2 with the 1 minus. Now I'm going to do my crisscross, but remember, sometimes it's just easier to throw the parentheses around your polyatomic right after that, because the 2 will come out here, the 1 will come here. Remember, crisscross just the number, not the charge. You just want to know how many you need. So tin nitrite is SN. NO2, 2. Alright, that was tin nitrate. Now cobalt 3 oxide, cobalt 3 oxide. You're going to crisscross, bring your 3 down, bring your 2 down, and you get CO2, capital O, 3. Alright, I think we should try one where you have to find the charge. There's a few on that form where it's a little bit more challenging to find the charge. So what should we do? How about, maybe I'll make one up here. Let's say that we had, we have lead. Let's say we have lead, and you're given the chemical formula, and you knew that it had bonded with, let's say, sulfate, so SO4, but it took 2 of them. Okay, so this is an example of where you're going to have to use knowing your anion's charge to determine your cation's charge, because the cation here is a transition metal, so there's more than one option for a charge. So we can just start by saying lead, right? It's just spelled like it is, but I know I need to find the charge, and then I know that is sulfate. And if you look at your polyatomic table, you'll see that sulfate has a charge of 2 minus. Alright, so whether you want to do the reverse crisscross and then realize you gotta change some numbers, or just write out what you have. I have sulfate with a 2 minus, but I have 2 of them. And then I have lead, but I don't know what the charge is. So you're going to think to yourself, well, I've got something that's positive, and if I add -2 plus -2, I have -4 for my anions. I have to get 0. That means that this had to be a positive 4. So because of that, I'm going to write the Roman numeral 4 in parentheses, and that is lead 4 sulfate. Alright, hopefully that is enough of a review. Remember, these are all about ionic substances. And just simply ionic naming. Remember, this is the chemical name, and this is the chemical formula. You are always going to know at least the anion's charge or the cation. Usually it's the anion. The cation's usually the only one that we have the option of not knowing for certain. So just figure out what made the net charge 0, because that is the goal of all ionic compounds. Because you're going to have a cation, or a few, and anions, or a few, to get a net charge of 0. Remember, cat's positive, anion's negative, and you always name them cation to anion. Alright, good luck.